Hello everyone, welcome to today's class. This is teacher Simon taking you through Cambridge Igcse Equal Mathematics paper 3 October November 2024, part 2 for questions 6 to 9. Question 6, part A, the diagram shows a cuboid. On the 1 centimeter squared grid, complete the net of this cuboid. One face has been drawn for you. Now if you look at the measurements of this one, we are seeing 4 squares here. So that means this is 4 centimeters. And also this one is 4 centimeters. So either it is the base or the one at the top. So when we cut here, we cut here, we cut here. We also cut here, you cut here. Okay. Then you also cut here. We also cut here. Then we are going to see something like this. The one down, then this one here will fall this side, then this one this way will fall this side, and these two here are equal. Then this one here, this one facing us, is going to be down here. Okay, then it's going to be down. Then this other one here, 4 by 4, is what is drawn. It is this one. Then the one on top here, okay, the one on top, this one falls this way. Then we have this, then the other one behind, this one here behind there, this and this are equal. Then the one that comes after here, this one is the same as this one here, those ones. So that's what we are going to have here. So when we are drawing, this is 4, then we can see that the length is 4, the width is 4, then the height is 2. So we shall draw here 2. Now we'll go 4 down here, then also here, then also here, like that. What is here must be the same as what we put here, such that when you fold them, the same thing, what is here must be the same as what is here, such that when you fold, they fit onto each other. So we are going to have 2 here, then like this, and then we go down that face we have put up. This one is the one that comes also down here, because we are having 2 congruent faces that are opposite to each other. And then the one that is in the middle, we draw 4, and usually the way they give you the net, how it is supposed to be drawn, it always balances on the grid. You can see that here we are remaining with 3 boxes, see. Then this way we have 1 down and then 1 up there, so it always balances. So that is our net. Part B, 3 regular pentagons meet at a point A. Work out the value of x. Now this is an interior angle of a pentagon, even this one and this one. So that is what we need to find. For any n-sided shape, let's say this pentagon here, let me use the pentagon. I can look at the number of triangles which are formed. You see, those ones are 3. The n is 5, but the number of triangles are 3. If I look at a hexagon, you draw the triangles from the same position. These ones are 4. N is 6, but the triangles are 4. Then when you look at a quadrilateral, N is 4, but the triangles are 2. You see that it reduces by 2, by 2, by 2. So that means the number of triangles for an n-sided polygon, number of triangles is equal to n minus 2. And remember, each triangle sums up to 180 degrees. So meaning interior angle of a regular pentagon is going to be equal to n minus 2. Okay, so n minus 2, that will be now 5 minus 2, then times 180. Okay, this is the sum of the angles in the pentagon. Then we are dividing by n because all of them are equal. Okay, all of them are equal. So when you get your calculator and you put 5 minus 3 minus 2, that is a 3 times 180, and then you divide by 5, 108 degrees. So meaning now we shall have x plus 108 plus 108 plus another 108. Then this one will give us 360 degrees. Why? Because angles at a point add up to 360 degrees. So my x is therefore going to be equal to 360 degrees minus 324. When you add all of this, and the answer becomes 36. Okay. Alternatively, somebody could begin by finding the exterior angle of the or let's say exterior angle of the regular pentagon. This one is 360 divided by n, so divide by 5. This one gives you 72. Okay, then that means that the interior angle will be equal to 180, then minus the 72, because for any polygon this is the interior angle, then extend this one, this will be the exterior angle. They lie on a straight line, and then you get 108. See, then you can now come back to this one here, see that, and then you proceed. So this is also another way of finding the interior angle, by first finding the exterior angle. Next, the diagram shows 2 parallel lines and 2 straight lines. Roman 1, find the value of x, give a geometrical reason. So when you look at x, because these are parallel lines, this one here corresponds to this angle here. So that means x is going to be equal to 23 plus 35 degrees, and that will be 58. So the reason is going to be corresponding angles. So you can just write here corresponding angles. So on parallel lines, you must know something about corresponding angles, then alternate angles, that this one is equal to this one. Those are alternate angles. And then we also have what we call interior angles. The interior angles add up to 180 degrees. If this is A and B, the A plus B equal to 180 degrees, you see. So things of the sort, must be knowing them. And then next, find the value of y. This is corresponding angles. Find the value of y. Now, to find the value of y, we have here 35. So this is an opposite angle. Okay. So that means we shall get y plus 35 we equate to 180 degrees. Just like I've just said, it is interior angles, okay, on parallel lines. On parallel lines add up to 180 degrees. So that therefore implies that y is going to be equal to 180 minus 35. This one gives you 145. Question 7, part A. The universal set is equal to the students in the group. M represents the students who pass mathematics test. S represents the students who pass the science test. 142 students are in the group. 105 students pass the mathematics test. That means for the whole of this set, when we add everything together, that is 105. Then 82 students pass the mathematics test and pass the science test. That means the 82 is here. Okay. And then 17 students do not pass mathematics test and do not pass the science test. That means it is outside here. So they are saying now complete the Venn diagram. So we shall begin with 82 here for both of them, and then the 17 here. Now, for us to get what is here, we shall get the total, which is 105 for those who pass mathematics minus those who pass both. Okay. So putting this in the calculator, 105 minus 82, that one will give us 23. So we shall have 23 here. And then to get what is here, they didn't give us the number of students who pass science. Okay, all of them. So what we shall do, we shall get this universal set, 142, then minus everything that we know. Those who pass mathematics, the whole of this is 105. So I will just put 105. And then there is 17 outside here. So plus 17. And then when we put this one here, 142 minus 105 plus 17, then this one gives us 20. So this is what we are going to write here. Next, find the number of students in M union S. M union S, you are supposed to get everything here and you add. So this one is going to be 23 plus 82 plus 20. Okay, 23 plus 82 plus 20. This one is 125. One of the students is picked at random. Find a probability that this student passes the science test but does not pass the mathematics test. Passes the science test but does not pass. So this is the same as looking for. They pass the science test but not the mathematics test. That is for science only, which is here 20. Okay, that is 20. Now the probability of S intersection M prime is going to be 20, then divide by the total, which is 142. So simplifying that by 2, I can get 10, then this one by 2, it can be 71. You can even leave the answer as 20 over 142. They didn't say give your answer in the simplest form. Okay. So then next, part B, use the set notation to describe the region. This is the intersection of the two. So I'll just say A intersection B, as simple as that. But see, in a town, the number of students N who take the science test is 10,600. Correct to the nearest 100. Error bounds, here is what we are supposed to do. So complete the statement. Now, if it is correct to the nearest 100, it's like you're having this 10,600. Then the next one is 10,700. The one before is 10,500. Okay. Then we look at the middle here. Okay. The middle here. So this 10,600 begins from here, 10,550, and then ends to be so at 10,650. Because when you round this off, it will now go to a 7, and when you round this off, it will give you the 600. So all the numbers here will give you that 10,600 when you round them off. So that means we shall have 10,550, and then here we shall get 10,650. As simple as that. However, in the calculation we can say, let's find the error bound. So error bound is going to be that 100. They have said it is correct to the nearest 100. You divide it by 2, then you get the 50. Why do we divide by 2? Because we come this side halfway, and we also go the other side halfway. So half of 100 will be 50. So you go to the left and then go to the right. Then lower bound. Lower bound will give you 10,600 minus 50, which is 10,550. And then the upper bound is equal to 10,600, then plus the 50 here. Then this will give you 10,650. Now you have to be careful. You can calculate your things here correctly, but then when you are substituting them here, you find some people always put this one here and then this one here. That is wrong. The upper bound is the big number, the lower bound is the small number. And I want you to look at here. Why do we have less than or equal? It's because all the numbers from this one and greater than, they give you the 10,600. Okay, in this region they give you the 10,600. But the numbers here, they also do the same. But when you come to this one here, the 10,650, when you round it off, it goes to 700. So it's no longer 10,600. You get it? So that's why they say less than this value. It's not less than or equal. So that is what we have there. Part D, the table shows the number of students in another town who took the science test in 2022 and 2023. Calculate the percentage increase in the number of students. So the percentage increase is going to be equal to the increase. So you get the new value minus the old value. So the new value is this one, which is 17064, minus the old value, which is 15800. Then we divide by that old value, or you can call it the initial value. Then you multiply by 100. So you get your calculator. We put 17064 minus 15800 out of 15800, then times 100. That is 8. So I'll put 8%. The number of students who took the mathematics test in 2022 is 18,400. The ratio of the number of students who passed to the number of students who did not pass is 4:1. Work out the number of students who passed. So the number of students who passed is going to be equal to number of students who passed is here, so it corresponds to the 4. So it is going to be 4 out of the total, which is 4 plus 1, then times the total number of students who sat, that is 18,400. Then we shall put 4 over 5, then times 18,400, and that is 14,700. So we shall write 14,720. Question 8. Find the equation of line L in the form y is equal to mx plus c. So c here is the y-intercept. This is the y-intercept where the line crosses y-axis. And for this case, c is equal to 2. Then this one here is the gradient, the change in y over the change in x. And on the look of things, the gradient here, you just get 2 points and you connect them. I can even just get this one here. This one, I connect it to this one here. Okay, just like that. We make it dotted so that it is different from the line which was already drawn there. So that is that. The change in y, these are how many boxes? 6 and 4. What is the difference between 6 and 4? That is, 6 and 2. That is a 4. So this is a 4 here. And then the difference between 8 and 0, that is 8. So we shall have 8 here. And since this line is going like this, then it has a positive gradient. Okay, so the gradient is going to be positive 4 over 8, which is the same as a half. Okay, which is the same as a half. So that therefore implies that we are going to write y is equal to a half of x, then plus 2. Then Roman 2 part A, complete the table of values for this one here. So when you put 0 in here, 8 minus 0, that will be 8. And then when you put 4 times 2, you get 8. So 8 minus 8, that will be a 0 here. And then on the grid, draw the graph of y is equal to 8 minus 2x for 0 to 4. That means we shall come here and put 0, 0, 8. So 0, 8. 0, 8 to 4. Okay. 0, 8 is here. So we plot that. Then we have 2, 4. 2 and 4 is here. So long as you have 2 coordinates, you can draw a line. Then 4, 0. 4, 0 is here. Then we are now going to draw that line. So the line is going to be from here. It's going to be that there. Then you can even label it and you say this is y, which is equal to 8 minus 2x. Then they're saying the next thing, find the coordinates of the point where the line intersects the graph y is equal to 8 minus, where the line L intersects the graph of y is equal to 8 minus 2x. So the point of intersection is here. Here. So you can use your ruler and you extrapolate just down there. This is the one here. Then you also check the y coordinate here. Okay, can make this one a little bit dotted. It is an extrapolation. Okay, then after that, which values do we see here? What is the equivalence of a small box? One small box here is equivalent to, because we are adding on 1, so 1 out of 5, because there are 5 small boxes within, that is 0.2. The same thing up here. So that means here we are having 2.4, and then this way it is 3.2. So 2.4 and 3.2. 2.4 and 3.2. By the way, this is solving simultaneous equations graphically. We can solve linear simultaneous equations using elimination, substitution, graphical, like that. And also there is matrix method. So this was graphical. Then B Roman 1, complete the table of values for this. We put -1, so we'll be substituting all of these values here. But if you have a good calculator, you can just put each and everything there, and then it gives you the answers. So you just come to mode, and then you look for table. Table, that is option 7. Then they're asking for the function. So you press alpha, then this bracket here to give you the x, then squared, -4, again alpha, then x here, then -4. You press equals. Start. Where are we starting from? We are beginning from -2. So I write -2, then I press equals. And where are we stopping? +6. Okay. The last one is +6. I press equals. Then they are asking me for the step. What are you adding on every now and then? So you can see that we are adding on 1 unit, 1 unit, 1 unit. Okay. -1, 0, 1. So the step is 1. I just press equals. Then it gives me the answers. So for -2, I think you can see we have 8 for f of x. Okay. Then -1, we have 1. So that is 1. I'll write 1 here. Then check these others. The next one for 0, then -4. Then we can check down. 1, -7. Let me put like 3 of them. 1, -7. 2, -8. 3, -7. So we have -7 here, and then -7 here. Then the next one, we go to when x is 5, then we are having a 1 here. So that is all. See? Next on the grid, draw the graph of y is equal to x squared minus 4x minus 4. This is a quadratic equation. And now we plot. We have our values here. -2, 8. So -2, 8 is here. Then we have -1, 1. We have 0, -4. 0, -4 is down here. Then we also have 1, -7. 1, -7 is down here. 2, -8. So 2, -8 is here. And then the other one is 3, -7 is here. It's a symmetrical graph. 4, -4 is here. For -4. Actually, let me be putting the circles to make it look very good. The circle you put, make sure it is not all that big. Then the next one is 5, 1. 5, 1. So we have here, it's too big. So 5, 1. And then 6, 8. 6, 8. So you come back here. Like that. And then we are supposed to draw that. So, okay. Now, before you draw this curve, always look at the questions that come after the graph. So there is this one. Use your graph to solve this equation. So this is our y, then is equal to 0. 0 is the x-axis, where y is 0 is the x-axis. Now you look at where that y cuts x-axis. So faster, you can come to your calculator here. You can press mod, then we can go to equation is 5, then 3, then you can solve this quadratic here, 1, then -4, then -4, like that. Then you get 2 plus 2 root 2, then that will be 4.82 whatever. So then you can go to your graph and you put a dot at 4.82 and well, but you can put it at 4.8 just there. Make it silent there. Then the other one is x2 is that, which is -0.82 there. So -0.8 probably is here. Now, when you are drawing your graph, you make it pass through those points, then you will produce a perfect graph. That is how you can cheat the examiner. Okay. Now, we are going to connect our points here. So we connect. Make sure you draw a smooth curve. Let it pass through your point here. Then you go down like that. Pass through that point there. Then you go connect this one to this. Then continue down. No. Then you curve it off like that. You also bring this one here, and then you curve it off like that. That will be our graph like that. If I can reduce, that's how it is going to be. Then after that, they are saying that write down the equation of the line of symmetry. That is the one that divides the curve into two equal parts. You can simply see it passes through the turning point, this one here. So this is the vertical line, x is equal to 2. Okay, that is x is equal to 2. I can even draw it for you here. It's the green one, this one here. X here equal to 2 is the line of symmetry. So just write here x is equal to 2. Or we have this equation, x is equal to minus b over 2a. So for a quadratic equation which is given by ax squared plus bx plus c, now the b is a -4, so we shall have negative of -4 out of 2 times our a is the coefficient of x squared, which is 1. So you have 4 over 2, which gives you 2. So then it will be x is equal to 2. You see that? So you can keep this in mind. The equation of the line of symmetry for a quadratic curve, it works for the quadratic curve, not every equation, not every curve. So where for this one here, we are now supposed to look for where it cuts the x-axis. So like I said before, already you did it, but if you didn't do it and you just drew, you just look at where the curve cuts x-axis. So at that point and at that point. So me, I'm going to write, but the value you give must be the one that is actually there on the graph, because they have told you to use your graph. So this is going to be -0.8 and then 4.8. -0.8 and then 4.8. Now, since we all don't draw the same smooth curve, they always give a range of values. So here, your values must be within this range, negative 0.7 to negative 0.9, and then here it should be within 4.7 to 4.9. Question 9 is coming from transformations. Part A, on the grid, translate the triangle T by vector negative 5, 4. Now, when you look at these grids, X increases this side, it is positive. Then this side, it is negative. Y increases this side, it is positive. And this way, it is negative. So meaning, in the vector, here we have X and Y. So when it is positive, then we are moving to the right. When it is negative, we are moving to the left. When Y is positive, we are moving up. When Y is negative, then we are moving down. Okay, so we are now going to have rub off everything here. So that means we are going to move 5 units to the left. 1, 2, 3, 4, 5. Then 4 units down. 1, 2, 3, 4. So we shall be here. Okay, at negative 4, 3. So here, then you don't need to waste time because translation is a shift. So all points move like that. So to the left, you can put 3. Why? Because here there are 3. Then here it's one that is passing through the diagonals. So that means I can connect this one here through this one here, and then that, like that, and then now join this one here. So that will be our part A. They have not told us to label it, but just to be so smart, you just put this is part A. And then describe fully the single transformation that maps triangle T onto triangle A. Now, I have already said that you look at the number of marks that are given. If it is 2, you think about reflection, because you tell us the reflection and then the equation of the line. You say reflection in the line, which line, give its equation. Then the other one is translation. Okay, you tell us translation, then which vector, you give the vector. Okay, and then if the number of marks are 3, you think about rotation, because you tell us rotation through which angle. Is it 90 degrees clockwise or anti-clockwise? Even the direction has to be there. Then after that, you also tell us the center of rotation, or you can also think about enlargement. Okay, enlargement, then tell us the scale factor of enlargement. Then after the scale factor, then you also tell us the center of enlargement. So those are the 3 marks. Then now we come to this one here. It is 2 marks. Since we have done translation, this one has to be reflection. So you need to get the line of reflection. So the object and the image must be equidistant from the line of reflection. So look, this is 1, 2, 3, 4. You divide it by 2, you get 2. That means from here I need to move 2 squares, and also from here 2 squares. That means the line is this one here. Okay, so the line is going to be I want to now draw it, put it in green, this one here, and even make it a little bit dotted like that. That is y. Y is equal to -1. So we shall say reflection. Here you get a mark for saying reflection. Then in the line, y is equal to -1. So this is the second mark. Next, describe fully the single transformation that maps triangle T onto triangle B. Do you see that it is 3 marks? So we are thinking about enlargement and rotation. And for enlargement, the points must be the object and the image must be of different sizes. But for reflection, rotation, and translation, the object and the image are of the same sizes. So on the look of things, when you look at B, it is the same size as A. They are congruent shapes, so that is rotation. Okay. And for core, currently they give you when the center is O, when the center is the origin. If the center is not the origin, then they tell you to rotate. Okay. To rotate maybe at a point on that given shape. Okay. When they use another point, that is majorly for extended. So if you can just connect this one here and then to this one here, the angle in between them is 90 degrees. Okay. This is 90 degrees here. So I will say rotation here, rotation, that is the first mark. Okay. Then through 90 degrees. Your 90 degrees, is it clockwise or anti-clockwise? Okay. When you look at this, I think it has to be anti-clockwise because this part here came here. If it was clockwise, this part here would have been like this here, and then this one goes like this side, you see. So this is anti-clockwise. Even when you get your tracing paper and you put it here, then you trace this T here, and then you put it at 0 as your center, and you rotate anti-clockwise, you will see that it lands at B. So 90 degrees anti-clockwise, add it there, anti-clockwise, like that. This is the second mark. Then center 0, 0, or you say center, the origin. So those are the 3 marks. If you don't say 90 degrees clockwise, it can be 270 degrees clockwise. So that's why it is very important to tell us whether it is clockwise or anti-clockwise, because when you rotate 90 degrees clockwise, it's not the same way you rotate 90 degrees anti-clockwise. You see that? All right. So that has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.